What's up guys, my name is Josh. Today we're talking about headphone amplifiers and what they do. In simple terms, they take an input signal and then they push it out the other end with a lot more force. Think of like a Hot Wheel track. You have a Hot Wheel coming down the track and then it hits one of those spinning rubber wheels and then it shoots out the other end of that, going a lot faster than it was when it came in. Now that's kind of a really basic explanation, but I like that example. I'm going to continue building on that. So before I get into what exactly it is that amplifiers do, I need you to understand three terms and what they are. Term number one is watts. A watt is about a joule per second, and you can kind of explain it as being a way to quantify the rate of energy transfer. So to the Hot Wheels, think of it as certain speed, 100 miles an hour, let's say. So an amp would take a 50 mile an hour Hot Wheel and push it out the other end at 100 miles an hour, and that would be the watt. It's going 50 miles an hour. And so you can kind of imagine watts as being the speed at which the car moves. Now voltage, on the other hand, is kind of the force behind the watt. So imagine that you take a 50 mile an hour Hot Wheel and then it pushes out the other end, not only going 100 miles an hour, but it also is the full-size car. So you started with a Hot Wheel, now it's a full-size car. And then OHM, otherwise known as ohm, is the amount of resistance that the car meets. Ohm can be measured as resistance. So you could think of a car going through the air has a certain amount of resistance, and a car hitting a brick wall has a certain amount of resistance. So that Hot Wheel needs a whole lot more watts and a whole lot more volts to actually get through that brick wall. That's sort of what an amplifier does. So to kind of group this together, basically an amplifier takes a signal or a Hot Wheel and then pushes it along something that speeds it up, gives it more force, makes it larger, otherwise known as watts and amps, or turning it into a big car and increasing the speed as well. And that allows you to fight resistance, otherwise known as ohms or brick walls. Okay, so now we understand kind of what they do. Now, why would they sound different? Because you would think that it wouldn't matter what came in and what came out. So a signal from, let's say, an iPhone at the same volume as through a headphone amplifier, why doesn't it sound the same? For this, we need to understand what exactly an amp is doing to the signal and what kind of signal it's receiving. So computers work off of binary signal, so it's a consistent 1 or 0. This type of signal is considered a digital signal. So what amps do is they take an analog signal, so a lot of times you'll hear the term DAC or DAC, and that is a digital to analog converter. So it's taking a digital signal, a series of ones and zeros, and turning it into an analog signal. So imagine this as your series of ones and zeros, right? This is 1100, this is 11010, 1010101, 102, and they mean different things to the computer, right? Well, your DAC is gonna take this information, take all these levels, and it's gonna turn into this smooth line. So what this is doing is turning a staircase into a slide. What the actual amplifier should be receiving is an analog signal. A lot of the amplifiers that you can get nowadays have a DAC and amp combo, so they first go through the DAC, they convert it to analog, they give it to the amplifier. Now, the problem with the amplifier, the reason they sound different, is because similar to how they are receiving this smooth line rather than the choppy digital signal, is similar to a pair of glasses. Now, the actual materials and the efficiency of the circuitry involved in the amp can determine how it sounds both to the amplifier when the signal comes in and to the amplifier and the listener when it goes out the other end. If you think of it like glasses, some glasses have clear frames and some don't. So they're taking the same signal, but it's coming across on the other side differently, either more colored or darker or even slightly distorted, based off of which glasses it's going through. Now, this is different because of the actual material and the properties of said material that's actually passing through what it is. Now, an amplifier, unlike the Hot Wheels scenario, where it's taking something and then just speeding it up. So what amplifiers do is actually slightly more complicated. They take a signal that's coming in one end, and then on the opposite end, they don't actually ever pass through. The signal that comes in is not the signal that comes out. The signal that comes out was reproduced by the amplifier. Think of it like a copy machine that puts something in and it comes out 10 times bigger. Now, depending on the capabilities of the actual amplifier, how much power it has, how much power it can take in, how much it can put out, you'll have different reactions. But for the question of why they sound different is because of the material as well as the electrical circuitry and the quality that the copy that comes out has. Theoretically, in a perfect world, an amplifier would have an exact 1-to-1 ratio, just with more power. of the signal that was coming in. It would be exactly the same coming in as it is coming out, just bigger. Now, we don't live in a perfect world, which gives imperfections, sometimes even purposeful imperfections. Some amplifier companies are trying specifically to have either a more flat sound signature, or something with deeper bass, or something with higher highs, and they use different materials and circuitry setups that complement whatever their goal is. So this has kind of been a more basic explanation of exactly what they do, but hopefully it enlightened you a little bit, and you might have a little bit more knowledge than when you started watching this video. If you want me to go into what the actual electrical engineering processes that make an amplifier do what it does, leave it in the comments down below. I probably won't make one of those. I'm not an electrical engineer, so I'd have to do a lot of research, but if a lot of people request it, I will make it. Anyways, guys, my name is Josh. If you liked the video, like it. If you dislike it, dislike it. If you really liked it, subscribe to the channel. It would really help me out. Yeah.